Welcome back. We're still in section 8.1, but now we're going to tackle example 2, and we're going to graph some very simple quadratic functions. And as we go through the chapter, the level of quadratic function is going to get a little bit harder as we get deeper into the chapter. So we're going to learn, we're just going to keep layering knowledge on top of what we've learned, okay? In example 2, y equals 2x squared, this is the most simple kind of quadratic function because you don't have a bx and you don't have a c. Remember, standard form is ax squared plus bx plus c. So when you don't have those two terms, that's really very, very simple to graph, not complicated at all. So what we're going to do is we're going to use a table of values. And I'm going to ask you to create an xy chart, and the numbers we're going to consistently use are the following. We're going to use -2, -1, 0, 1, and 2. Now some of you are probably wondering, why are we using so many x's? Because when we did linear equations, I think I only insisted that you maybe do 3 points, calculate 3 points and graph those. With a parabola, we have got to see a trend. We've got to see, where does this parabola start bending? And we don't want to miss out on the shape of it. So I've had students in the past that just decided, oh, I'm just going to do 0, 1, 2, and they would only have half of the parabola. So we want to have enough of a number of numbers there so that we can see the trend, that it's going to give us that U shape that we're looking for. Okay, so let's go ahead and plug in. So we're plugging into 2x squared to find y. So first thing, remember, 2 times x squared. Order of operations tells you that you must square the variable first, whatever number you plug in, you got to square that first, then multiply by 2. That is order of operations. So let's start with -2. What's -2 squared? That's right, 4. 4 times 2, 8. Okay, let's go down to -1. What's -1 squared? 1. 1 times 2, 2. What's 0 squared? 0. 0 times 2, still 0. 1 squared? 1. 1 times 2 is 2. 2 squared? 4. 4 times 2, 8. Okay? So that's what we're looking for. So as I draw this particular graph, and I think what I'm going to do is I'm going to share the space, I think is what my basic plan is. I may have to erase. Let's see here. These boxes are just not big enough for me. So 1, 2, 3, 4, 5, 6, 7. That's fine. All right, I'm going to go ahead and draw this first graph. I'm going to do here. Just go ahead and be prepared. We're probably going to have to get some graph paper to do the second one. I'll stop the video for just a second to let you get your graph paper. You can do both of them on your own graph paper if you so desire. Okay, so let's take a look. All right, let's see. Our very first point we need to graph is -2, 8. So find -2 on the x and then go up to 8 on the y. So I'm way up here, very top of the graph here. It had just enough room to get that. -1, 2. So -1 on the x and 2 on the y. 0, 0. That's easy graph. +1 and then 2 on the y. And then 2 on the x and 8 on the y. Okay? Notice that they're mirror images. Okay? They're on the same level, and you're going to connect them together in a nice, smooth parabola, just like that. So there you go. You can't do any better than that. That looks wonderful. Excellently done. Okay? Now I'm going to erase just a little bit over here. Just kind of bring that in just a tad. I think what I'm going to do is just bring the next graph a little bit higher to give me some room to graph. Okay, yeah, let's do that. That looks great. I was able to figure out how to get it on there. All right, so again, I want to do an XY table, and I'm going to plug in my basic numbers here, -2, -1, 0, 1, and 2. And you're going to do the same thing, except you're going to multiply by -2. You're going to plug in, you're going to square whatever number you're plugging in, and then you're going to multiply by -2. That's the only difference. Okay? So let's take that -2 and let's plug it in for the x. We're going to square it first. So what's -2 squared? 4. 4 times -2, -8. Now plug in -1. -1 squared, +1. 1 times -2, -2. 0 squared, 0. 0 times -2, still 0. 1 squared, 1. 1 times -2, -2. 2 squared, 4. 4 times -2, -8. All right, so we have 5 points to graph. So on our graph, let's find -2 on the x and then go down to -8 on the y. All right, here's -8 right down there. All right, let's go to -1, -2. So there's -1 on the x right there, and then pop down to -2. 0, 0. We're going to do 1, 2, or 1, -2, excuse me, and then 2, -8. Okay? I don't know what's going on, why if I touch down there, it pops that up. I have no idea why, so I apologize. Okay, and there we have enough information. We're going to connect our points with a smooth arc here. And there it goes. There's our parabola. Mine's not that pretty, but I'm sure yours looks amazing. And there's our parabola. But notice that it's that upside down, that rainbow shape. There's that rainbow shape. But the first one was an upside down rainbow. So kind of a smile, you know, when you smile, the corners of your lips go up, you know. So cup shape versus rainbow shape. So basically we did the same exact problem. What was different in letter A than in letter B? What was different? Hopefully you were looking at the coefficients. We plugged in exactly the same numbers for the x's, but it's the coefficients that made it different. Notice if I have a positive coefficient, my parabola opened up. And when I had a negative coefficient, my parabola opened down. Isn't that interesting? And that's a pattern you're going to see over and over and over again. So you can tell before you even start graphing any of these quadratics, you'll be able to tell which way it's going to open. Is it going to open up or is it going to open down? You can tell all by looking at the coefficient out in front. That's all you got to do. Okay? So if it's a positive coefficient, it's going to open up. If it's a negative coefficient, it's going to open down. All right, let's get to this next page. I'm going to show you C, and then I'm going to let you try D all by yourself, okay? But I definitely want to show you C first. So we want to have our XY table, and we're going to plug in for X. And again, we're all going to use the same thing, -2, -1, 0, 1, and 2. We're all going to do the same thing. We're going to do that in letter D as well. Okay? -2, -1, 0, 1, and 2. There you go. So let's plug in letter C. You're going to square your variable first. So whatever you plug in, square that number, then add 2. All right, so what's -2 squared? 4. 4 plus 2, 6. What's -1 squared? 1. 1 plus 2, 3. What's 0 squared? 0 plus 2, 2. 1 squared is 1. 1 plus 2 is 3. 2 squared, 4. 4 plus 2, 6. Okay? So we want to get our graph prepared, you know, leave enough room where you can have 6 on the y. You're pretty okay on the x's. You don't have to drop terribly wide. But you need at least 6 on the y so you can get this graph. So let's go to -2 on the x and then go up to 6 on the y. 1, 2, 3, 4, 5, and there's 6 right there. Mark it. And then -1 on the x, +3 on the y. Mark it. 0, 2, mark it. 1, 3. Which is a mirror image of -1, 3. That's a pattern. This is the 3rd time that's happened. And then 2, 6, which is a mirror of -2, 6. And then connect your dots together. And there's your parabola. Should it open up? What's the coefficient in front of x squared? Right, it's a +1. So yeah, it should have opened up. We did this absolutely correct. All right, now, D is yours. So remember, follow order of operations. This says -3 times x squared plus 1. Order of operations says I got to square my variable first, then multiply it by -3, then add the 1. So make sure you are doing order of operations. You can do it on a calculator, or if you like to do mental math like I do it that way. And then I want you to create your parabola. You should have room on your graph to be able to do this. So go ahead and get your XY table filled in and go to town. Let's see what it looks like, okay? And good luck with that. Bring any questions you have to class.